Hey guys, it's Cody. Um, I was just gonna make a video. Hopefully it doesn't take too long. I'm gonna try to go fast, but be thorough for you. Spline interpolation. That's the topic I want to talk about. Had a lot of problems and took me a minute to get the hang of it and figure out how to do it. So what's spline interpolation? It's essentially making a curve for lines that are in between points, right? So it looks nice, if you're trying to build graphs or something, it's gonna look, make your lines curvy. I'll show you what it looks like before that spline interpolation stuff's applied to it. Um, Basically, I just made some points with some circles, then I connected the lines to it, and it was just like straight points, but they're straight lines that we connect. Can't really talk while I'm topping. So so there's the original line, and then I just kind of made it curvy. Um, so let's leave it like this for a second, and I'll explain it. Kind of. So I'm using SVG. So you see the SVG here. SVG, I think you should learn if you're a web developer. It's a really good tool to have. It's already in all the modern browsers. I believe Internet Explorer 6 even supports it. Don't quote me on that. Not sure, but it's. I mean, now you can really use it. It's already there. Might as well just learn it. Throw in the tag and let it be, in the DOM. You can actually inspect the element and everything in SVG, so it's really handy. um, I'm not going to go over how to draw the lines. That's path. This is XY coordinates. Move to, that's a line from move 1010 line 50 to 175 X and Y coordinate, and it just draws it there, and so on and so forth for all of these, and that's how that path gets there. So these are just the lines, this part. And you see the strokes purple, 2 pixel width for the line. Then I simply drew circles at 10 and 10, right? 50, 175, 83, 155, so on and so forth. And you see that one's filled in blue instead of red like the rest. But radius of 4, so that's how fat, or the radius of the circle is. Anyway, there's that. And then here is the actual curve part of it. So all I did is I drew some normal regular lines, and then let's see, from there I made some additional lines that are curved with cubic Bezier curves and quadratic curves. So this is the quadratic tag in the path. Path is really powerful in SVG. You can draw a lot of stuff in it, but anyway, this is the this is the quadratic curve. There's the cubic Bezier curve tag. What do I want to say? Control points. Got to talk about control points. So what is a control point? So a control point is a point on a curve. Okay. Which one do I want to do a demonstration on? So let's look at this. Let's look at this one, for example. So from here to here, okay? Just keep this in your head, from here to here, this segment. See how this purple line's here? It's got to curve somehow, right? Something has to make it curve. Something has to do that. What you do here is you put control points on this point and on this point, okay? A control point it comes out a certain distance, and think of it like kind of like a magnet. It pulls it in a certain direction. So if you can visualize like a point right here, it pulls the line this way. Then imagine, you can see this one a little better. Imagine another point right here that's like a magnet pulling on this line right here. but it pulls this one, right? Because this is the line that we're trying to manipulate, not the purple one. The purple one's just an example there. So it's a control point that pulls this line, and there's another control point here. So a cubic Bezier curve has two control points. Cubic Bezier has two control points, one on the line segment, right? So one here and one here. A quadratic one, which would be this line, because that line I drew with this quadratic tag, okay? That only has one, so that has like one control point here. I know that's kind of confusing, but this one you can see there's probably a control point like around right in here. That's really where it is, and let me try to just show you real quick. Circle. I'll try to graph out the control points real quick for you, or at least some of them. Get rid of that. Let's see if this worked. Yeah, see? Now you can kind of visualize it. It's a control point that pulls off of that. So this is linked to this point, okay? Don't get confused. This is linked to this point, okay? Don't confuse that. So I'll kind of make a little bit better demonstration in just a second, so you can understand how to position these control points, because that's the important part, positioning the control points. So we'll talk about that in a second, but let's see, let's get a couple more control points up here. So one, try not to make this video last too long, but at least it'll be here for some people who need help with it later. Okay. So one thing that I want you to notice is this point has two control points. Okay? This has two control points. This has two control points. Control point here and here, right? Control point here and here. Okay? Another thing that I want you to visualize, and so what I'm about to do is get into how to position the control points. It's what I'm trying to lead up to, okay? So couple things I want you to visualize. Let's do this. Visualize a line that goes there. Let's see if I can mimic it real quick. Sorry guys, just a second. Alright guys, sorry about that. When I was drawing this path thing, I left out the equal sign. So anyway, that was my bad. Okay, so what I was wanting you to visualize is a line that connects these points. Okay, so forget about this for a sec. Look at just this point. Let's mess with just this point. So there's two control points on each point. Okay, so for terminology's sake, this is actually called a knot. So let me see if I can do this. Can I draw on this? So a knot here. K N O T. Said I would never use cursive. Huh. It's ugly. Anyway, knot. That's a knot. Okay. That's a knot. Any place that actually connects two curves together is a knot. So I guess that's knot. I don't know. This is a knot. There's a segment. There's a segment. There's a segment. There's a segment. See, there's a segment. There's a segment. All these are knots. That's a knot. Segment, segment. Anyway, there's those. Those are called knots. How do you get the control points on these knots? And each one has two. Okay, so this is going to have two, one over here and one over here somewhere. One over here somewhere, like this, here and here. The start and end don't even have control points now that I think about it. So anyway, how do you get the control points? Well, take this for this one. You draw a line through it, right? How do you get how the line's positioned? Well, look at the points on either side of this knot. So this point and this point. So this is the point just before it and the point just after it, right? Draw a connection to those. This line here has to be parallel to this line here, okay? This line has to be parallel to this line. So for this segment, you would say you draw a line here. So you'd say that. I know it's not straight, but you do that. Then this line would be parallel with this line. And that's essentially how you would, get these two lines parallel. Why do you need them to be parallel? Well, after you get them parallel, so forget about this control point for a minute. You would draw a triangle, a right triangle, okay? And after you do that, that kind of gives you a, just kind of a base. From here, you would say this control point is equivalent to this point, so you'd get similar triangles. Okay, this will give you a height and a length, and then essentially you're going to draw similar triangles. So you're going to do something like this, right? And this isn't to scale. It'd be really hard to draw this triangle where this control point is. So it should actually be like this. It should be a triangle, right? It should be a triangle, and this control point is where the tip of this triangle is, right there. This control point would be where that triangle is. The tip right there, right? So there's that one and there's that one. That's how you get the control points. Draw that triangle, and these are similar triangles. Okay, similar meaning what? Same angles. They both have the same angles, and they have the same rotation. Because that's parallel to that, so it's the same rotation. How do you scale it down? So like, how do you get the actual, how do you get this? How do you get this and this and this? These lengths. Got to do a formula type of thing, and I don't know if I want to explain it. Let's look. There's the formula. Oh goodness. Okay, so part of the formula, so it builds off of this triangle. So you draw a triangle here, or a line, and then here. What do I have them labeled as? This is D 0, 1. That's 0, 1. That's D 1, 2. That line and that line. And these triangles that would be here would be drawn proportionally to this line for this triangle, this line for this triangle, and also there would be a scaling factor that would be inside of it too. And when I say scaling factor, I know it's getting boring, but it'd be T, and when you create the control points, you would actually send the scaling factor, and this would be this. So it really just depends on how curvy you want it to be. is your scaling factor, or curve factor, whatever you want to say. And this would range between, around 0.5, 0.33. This would be the range. It would range between those. T would range between that. And that's just how curvy you want the triangle to be, or the line. I don't know, it's getting to be hard to explain, but so yeah, what you would do is you would multiply. So you use this formula to get the D1, and then the D12 lines. I mean, you just get, x1 and x, this point's x values, this point and this point's y values, and raise it to the power, and you square it so it's not negative after you do the subtraction and adding, and let's see. Anyway, that gets these lines here, and then once you do that, this is how you scale the lines. Just plug this in, honestly. You don't really need to even know how to do it. Here's the code. Anyway, what that does is that just gets you the D01 and D12 lines, scales it correctly, and then these are your control points. That's your control points for your lines. So when you pass the stuff into this function, you pass the coordinates, so first, second, and third point, x, y coordinates. So what does this 83? So first coordinate is this one, second coordinate is this one, third coordinate is this one. And that's what you would pass in with your scaling factor, how curvy do you want the line to be, and that's really it. It'll calculate it for you, and then it'll actually return 1, 2, 3, 4, 2 points, right? So when you do this, you want your middle point. This is the middle point, right? This is this point. So this is going to return P1x, P1y, 0.2x, 0.2y. It's going to return this point and this point. One thing I want you to understand is when you put, here's the start, middle, and stop points into the function. Start, right, middle, stop, start, middle, stop. When you put those into the function, I want you to understand that it's actually going to return this point and this point. It's kind of funky, I know, but it splices the points on the return. It'll give you this point and this point. So if you want to get this one, you'll need to calculate this triangle, and so if you calculate this triangle, it'll return this point and this point. If you calculate for this triangle, it'll return so we just got that one and that one. Now it's going to return this one and this one, and so on and so forth. That's just kind of how it works. So make sure that you're doing it correctly and putting the points in correctly when you do these type of things. It does this because it's actually dealing with a particular line segment. So all it really cares about is a line segment, right? So when you're trying to curve a line, all you're really trying to curve is the line segment. This one, or maybe this one, or maybe just this one. And the point of getting these control points correctly with these parallel bars makes it where this curve right here, this part, would match up with a curve on this part, so it makes a smooth transition on the knots. So that's kind of why the points are separated from this knot, is return this one and this one, and this one, you know, would just return that. But the reason why the control points are separated among knots is because it's not really looking at the knots, it's looking at, in a way, just the line segments. So just put those in correctly again. That's how you get the control points, and that's how it curves the line appropriately. It returns them, you put them on there, and then look up how to draw Bezier curves. So here's your first control point, here's your second one, and here's where you want it to end for the drawing. So your first one, right, your second one, and it goes here. Anyway, you can just play with that. Just make sure that you put these correctly, you know, on your paths. So like 83, what's it end at? My bad. Okay, so 111.93 would be the one right previous to this, because it's going to end at 120, 100 here. 111.93 is right here for this point. That's the second control point. So be careful, like when you go to construct this triangle, this is before the point, draws 2, this is after the point. So when you put this triangle in, it's going to give you this point back and this point back from that function that's called here that gets returned. Anyway, I know it was boring, sorry, but at least you can see how to get these control points. It's based off of this triangle, and this is the scaling factors along with that t constant that ranges between 0.33 and what, 0.5 or something. Sorry, I'm getting lazy. T. And then similar triangles get you the actual control points position, similar triangles that are similar to this triangle. Alright, thanks guys for watching. That's spline interpolation with cubic Bezier and quadratic lines in SVG.